Thank you so much for your presentation, April, and thank you so much, everyone, for being here at my presentation. It's really great to see similar faces after the Florida convention, as the last participant said. So today, my presentation will be to present another part of the project, try to understand the issue with the sulfide-bearing aggregates. So I'm Rodolfo Castillo-Araiza. I'm a PhD candidate at University Laval, and I am under the supervision of Professor Benoit Fournier and Josette Duchen, and working in collaboration with Pierre-Luc Fecteau, who is a research professional in our group. So to give you a little bit background of where are we working, it's in a particular case in the city of Trois-Rivie in Quebec province in Canada, where some sulfide-bearing aggregates were using to make concrete elements in the city for commercial and residential buildings. And these particular aggregates, as you can see here in the picture, contain some iron sulfide minerals, a really big quantity of iron sulfide minerals that with the time and with water and oxygen will react and will generate a lot of cracking and deterioration of the concrete. So the owners has to really lift off their houses, demolish the concrete wall foundations, and reconstruct it again. It was a very big problem in the city, and it's still being a big problem under the city. So in my research program, we have different objectives, and one of these objectives was trying to understand how the environmental condition will affect the reaction of the kinetics of the reaction in the concrete walls. And that's what I'm going to present today, but I just want to tell you that part of my research was also to developing a concrete test, and we are already published a methodology, an accelerated method to try to evaluate the potential of the oxidation reaction of sulfide-bearing aggregates. And there is more papers going on different, with different reactive materials and how the concrete properties will be affected due to this reaction. So the objective of the first step of the project was to understand the environmental condition that will affect this harmful reaction. So we analyzed the temperature, humidity, and oxygen level in potential concrete walls with these aggregates, with these types of aggregates, and it was with collaboration with the National Research Council of Canada. So for that, we installed some sensors, temperature and humidity sensors, oxygen sensors, and a data logger where we can keep this data over a year period. So how was the installation? We have 3 different heights in the concrete wall. The important was to see the concrete who is exposed to the environment, but also how the concrete will be affected if it's underground or below the ground level. And we installed 6 sensors for temperature and humidity and 2 sensors for oxygen levels. So we went to some owners of the concrete with this issue, give us the opportunity to make the study in the city of Trois-Rivie. And for the installation of the sensor, it's really important to say that we measure in 2 depths. One was at the center of the concrete wall, the thickness of the concrete wall, and another near to the surface. And we protect the sensor with a PVC tube to avoid the interaction with the room condition. So for that, we apply a sealing with a fast-drying epoxy, and then every sensor was identified, and the acquisition system were strategically put in some room to avoid contact with water, humidity, or animal children that maybe can play with the system. So the first case is a house that we can analyze for 69 weeks. One of the conditions in this house, in this wall in particular, is that not all the concrete wall was exposed to the environment. So we have the opportunity to install 2 sensors in the room, so we can see the conditions that they have in the room also. And all the installation were with a 45-degree angle to avoid that the water can go inside. We try to eliminate all the risks that can damage the sensors and can avoid to obtain good data. So the first wall, we installed the 3 highs. The importance of this wall is that it's exposed one side to the environmental conditions and the other side is exposed to the normal temperature of the room in the house. And this wall, as I say, we can only install 2 lines. We couldn't reach to install the other, but it's exposed to the heating system of the house. And the 2 sensors that I already mentioned, we installed one close to the wall in the house. And the results are really interesting because we can see clearly here that when the concrete is exposed to the air condition, to the environmental condition, we can have really changes on the temperature. And in the room, because of the heating system, we mainly maintain the same temperature. Just here, when we turn off the heating system after the winter, the big winter in Quebec, it's when decrease a little bit, but return to the high temperature. But the most important result was with the relative humidity. And you can see two really important things. First, the 2 sensors who were protected for the ground level maintained the high relative humidity, but the other levels that were affected by the outside conditions and inside condition of the building, they really decreased and were really dry, almost arriving to 65% of relative humidity in 4 inches in the concrete wall. And this is also affected by the condition of the room, because in the winter, because of the heating system in the houses, we really decrease the relative humidity in the houses, and that may affect the condition, the internal condition in the concrete wall. So, and in terms of the oxygen level, the important is like only one sensor was capable to detect oxygen consumption, I can say, of the in terms of the reactivity of the iron sulfate minerals. But unfortunately, all concrete walls that we analyze, only this show a decrease on the oxygen level about 3%. So we believe that maybe some iron sulfate minerals were exposed near to the sensor and can detect the oxidation of the minerals. In conclusion, is, as I said, we see that the temperature is affected inside and outside, but the most affected measurement was the relative humidity. And also we see like isolation effect about the soil, but even though some sensor can reach until 60%, and as I said, the only sensor who reached a decreasing on the oxygen level was the sensor number 13. Another case is another house, really important, these results. Unfortunately, this house we can only measure during 52 weeks because the owner decided to demolish the house because of the level of damage that it has itself. But the important thing in this house is that we can analyze an inner wall in the house. And the results are really interesting. This one also, it was exposed to the heating system, and in the outer wall, it was the same condition, outside, inside, but the inner wall is only inside condition of the house. And the results are really important because we can see there is not a lot of variation in the inner wall in terms of temperature, but we can see that there is a cycling on the temperature in the outer wall. But the most impacting results is of relative humidity. We can see that the inner wall, it has around 50 to 40% of relative humidity due to the heating system that we have in the house, the drying condition, but the exposed, it was with a higher relative humidity. And this is really important when we talk about corrosion rates, because we know that when we have a higher relative humidity, there is a medium probability that we can generate corrosion of oxidation. But when we decrease the relative humidity, we decrease also the probability to have corrosion. I'm not saying we are going to stop, but we decrease the possibility that it happen. Just to show you the last result on this house, is really important that there is no changes in the oxygen sensor levels. So unfortunately, it was only one sensor who can show something about these results. The most important is like in this house, we can see all the signs of damage due to the oxidation reaction of sulfide-bearing aggregate. And until today, no inner concrete element has been reported with damage. I mean, who has not been exposed to environmental conditions. So we think that the lower levels of the relative humidity may play a big role on the reaction, or the kinetics of the reaction. And we think that between 65 to 100% are the ideal condition to have this reaction happen. And this is a picture of the condition outside before the demolition of the house. The first picture I showed at the beginning of the presentation is also from the same house. Another important result for other houses that we analyze, this is two walls. This wall was exposed to the heating system, but in this house, this wall is not affected for the heating system. There is a room that is not in contact with the heating system of the houses, so we can see how in this wall, even at 4 inches, we can arrive until 0 degree inside of the concrete wall, and this make a very big play role on the kinetics, because different oxygen and hydroxygen oxides will be formed depending on the temperature that we have in the concrete. So it can maybe make change in the kinetics of the reaction. At the same time, we have here, when it's exposed to the heating system, we can see clearly that it's affected by the, and we have a decrease about 10 to 15% of the relative humidity. And when relative humidity play a big role in the way that the oxygen and hydroxyl products of rust can be formed, and we can see when we are close to 65%, we are going to generate more oxidized than when we have a low relative humidity or a high relative humidity. It's still forming, but it's less strong. So in general conclusion, it's all the oxygen levels show the similar level like in the nature. And in the concrete walls, we saw that the sensor who was closest to the surface tends to have an equilibrium with the room, and also the insulation effect of the soil that can protect and have a high relative humidity. And we are thinking that this cycling with the low and high relative humidity in summer and winter conditions may play a big role in how the kinetics of the reaction is going, and if the concrete will be affected over the time. just to say, like, during the summer we have high humidity, and in the winter we have low relative humidity. And just to final my presentation, I would like to invite everyone. We will hosting a conference on iron sulfate reactions in Quebec, Canada, from 14 to 17 May in 2024. In May 14, we will have a visit on the quarries that I present at the beginning of the presentation. 15 and 16 will be the conference itself with the presentation, and maybe we will have a petrographic course about the kinetics of the reaction in concrete specimens in May 17. For all more information, here is the website and the contact of the person if you have more are interested to go in. So thank you so much, and if you have any question, I'm here to answer.